are you? I hope you are doing well. So today we will learn about a very interesting topic, that is arithmetic progression. So first we will learn arithmetic progression, but why we use, where we use, and from where it comes. So before discussing about progression, we will discuss about what is sequence or what is series, and what then we will go through the progression. So first one is, what is sequence? Sequence. It is an arrangement of any object with a definite order. Arrangement of any objects with definite order. For example, let's say sequence of prime number. So sequence of prime number will becomes 2, 3, 5 and so on. Or we could say sequence of composite number, which will becomes 4, 6, 8, 9 and so on. Here we can see that they are following some rules, but we can't get the nth order. So say that if we need to find the 20th term, then we need to go through every object. Then we need to know what series. What is series? Series. Sum of objects of a sequence. Let's say sum of this sequence becomes 2 plus 3 plus 5 plus 7 plus 11 and so on, till where we want to get. So now we will discuss about the progression. So now comes to the progression. What is this? It is a arrangement of a sequence in which each term is related to its predecessor. It is arrangement of a sequence in which each term is related to its predecessor. For example, if we write 2, after that 5, then 8, 11, 14. Now we could simply see that here the difference is 3. Again the difference is 3. So this difference is continuing. Let's take another example. Let's say 2, 4, 8, 16, 32. So here we could easily see that each term is multiplied by 2 to get the next term. So there are basically three types of progression. The first one is the same arithmetic progression. second one is geometric progression, and the third one is harmonic progression. So we are here to learn about arithmetic progression. So what is arithmetic progression? Arithmetic progression, it is introduced by Frederick Gauss. When he were in class, then a teacher asked him that find the sum of a number from 1 to 100, and then he find what arithmetic progression. So what is arithmetic progression? It is a sequence whose each term is increase or decrease start कर दीजिए. So arithmetic progression. What is arithmetic progression? It is a sequence whose each term increases or decreases by the same amount each time. Let's say examples. If we take 5, 8, 11, 14, 17, so on. So here we can see that each term is increasing by 3. Let's take another example. 6, 10, 14, 18, and so on. Here each term is increasing by 4. Let's take a decreasing AP. 8, 5, 2, minus 1, so on. Here we could see that each term is decreases by 3, and that this difference, which is equal to all, is known as common difference. Common difference. The general term of an arithmetic progression. If we write an arithmetic progression, let's say the first term of the progression is a, and let's take the common difference d. The second term will becomes a plus d. The third term becomes a plus 2d. Fourth term will becomes a plus 3d, and so on. If we want nth term, then what it should be? Just look at here. The first term is a, second term is d, and third term is 2d. We could easily observe that each time this d is 1 less than the number of terms. If we take fourth, then we are getting 3. So if we need to find nth term, let's say if we need to find 10th term, then what it would be? It would becomes a plus 9d. Let's find nth term. It will becomes a plus n minus 1d. This is the general term of an AP. Tn, general term, is equal to a plus n minus 1d. Let's find out the sum of the AP. Let's find sum of arithmetic progression. We need to find sum of n term of an arithmetic progression. That is, first term a, second term is a plus d, third term is a plus 2d, and the nth term will becomes a plus n minus 1d. let's write it in reverse order. It becomes a plus n minus 1d, but next a plus n minus 2d, and the last term will become a. Let's add this up. It will become 2 times of Sn, and here if we add this one, what we'll get a plus a 2a plus n minus 1d, and if we add up this second, we will get the same. Let's say a plus a 2a plus nd minus 2d plus d. Minus 2d plus d will becomes minus d, and nd minus 2d plus d will becomes minus d. So here we could easily conclude that it is n minus 1 times of d. When we will find the sum of third terms, then it will be the same as this. So this sum is written n times. This sum, same number, is written n times, and we need to find the sum. So as we know, if we add 1 plus 1 plus 1 till 10 times, it will becomes 10. So if the same number is adding up to n times, then we could conclude that it will becomes n times of the same number, n times of 2a plus n minus 1d. Now the Sn will be equal to, these two will come here by n by 2 times of 2a plus n minus 1